Let me continue with active and passive case. This for completeness, though I have shown the before the active how it is happening address to active, but I will take again that part and then passive, then I will try to show active art pressure coefficient, passive art pressure coefficient, how to find out. So, you can see this already I have shown once, and you can see that when there is active art pressure, that means the entire soil will not move. Actually, when because of the weight, this wall will move this direction, and then how much soil will go, whether soil up from here will go, from here will go, from here will go. So, that actually there is a limit. So, that limit is actually from here, if you draw a line with 45 degree plus 5 by 2, this is a line. So, beyond that soil will be intact, and this soil mass will move along with the movement of the wall, and this is active case, and when the movement will be there slowly, and at certain movement it will reach to the minimum value, and beyond that it will be considered as a failure. That minimum value is called active art pressure, and that one if you see in more circle, you can see that this was either sigma z dash or sigma v dash, anything you can draw, or sigma naught dash, anything you can write, all are same. So, how to find out this one? Suppose this is the wall, and so this is the wall, and I want to find out at this point. So, initially I have to find out gamma times. So, gamma times h, that will be your. So, if there is a water table etc., you have to subtract gamma into gamma w into h. So, so that means you have to, by this way you calculate sigma v dash at this point, and then slowly this sigma v dash will be reduced, and it will become finally in general sigma h will be in the smaller. That how to find out that? Initially at rest condition it is cannot multiplied by this, but slowly because of this movement this value will be reduces. So, like this, as I have mentioned before. So, this value will be coming to this. This was sigma v, this sigma h initially, then it comes here, then comes here, then comes here, like that. At failure, suppose this is here. So, this is minimum value, this is maximum value. So, from here I can, and they are principal stress. So, through this, that means I can draw a more circle, and since this is a failure minimum value and this is the point of tangent. So, joining these 2 points, that gives you the failure plane, and if you geometrically if you see that this will come 45 degree plus 5 by 2. I will show also that one later on. So, this value will be how much it will be, whatever sigma v dash we had there, sigma v dash multiplied by k times k a multiplied by k a multiplied by k a. K a is actually active art pressure coefficient. So, active art pressure coefficient like art pressure at rest there was a k naught. Similarly, active art pressure coefficient k a is there. So, you have to find out that. So, how to find out, we will discuss that. For the time being, I will just mention here that this sigma h or lateral pressure on the wall will be k a times sigma v. Whatever sigma v was there, if you multiply by k a, then you will get the lateral stress, that is active art pressure. Okay. So, at this point, and this is the failure plane. Similarly, if you have passive, suppose this is the wall, and because of by some mechanism, suppose we could push the wall, sorry, we can push the wall this direction, we can push the wall this direction by that arrangement, and you can see again when if you push the wall like this, like previous case, whether entire zone of soil will be affected, or whether particular zone of soil will be affected. So, soil within this zone only will be affected, and this zone will be how to determine. You can draw a line from here 45 degrees minus pi by 2 with horizontal, and then this complete in this zone, this is actually passive zone. This soil will only move along with the wall, and this you can see, and because of this the pressure on the wall will be, since it is coming this direction, pressure on the wall will be increasing slowly, and at some time it will reach to the maximum. If you apply further more than that, then the wall may fail or collapse. So, that is the end where actually it is reaching the maximum value, that is actually called passive pressure. If I see corresponding more circle for this, you can see here, you can see initially your sigma v was here, and sigma this is sigma h was there, k naught condition, and when it was active case, the circle actually moved this direction and finally it become tangent like this. Whereas, when it is a passive case, this pressure will be increasing. Okay. So, it will be now it will become this, so like this, like this, like this, like this, like this, finally it is here. So, this is the failure point actually. So, and this is actually in the passive case, horizontal pressure is the major principal plane, principal press. Active case, horizontal pressure is the minor principal stress, whereas in passive case, horizontal pressure is the major principal stress, because this is larger. You can see from here to here, this is larger. So, it become, so now from this, if I join envelope, tangent of envelope to the circle, and that gives you the failure plane, and geometrically again you can find out that this angle is 45 degrees minus pi by 2. So, this is the thing to be known, that means at rest condition, active condition or passive condition, how with respect to wall movement how it is, and again with respect to Mohr circle how it is. Mohr circle for at rest condition will be, Mohr circle will be much below the envelope, whereas in active case Mohr circle will be just tangent to the envelope, and originally whatever vertical stress was there, horizontal stress was there, that will be reduced, and finally it will reduce to a minimum value, and that is equal to active pressure, and that's Mohr circle will be tangential to the, that means circle originally that at rest condition, whatever the circle position, that will move towards left, and in passive condition the wall actually with respect to wall movement, wall will be moving towards the backfill, and then with this your pressure on the wall will be increasing, and as a result your horizontal pressure or lateral pressure will become larger than the vertical pressure, and your lateral pressure in fact will become the major principal stress. And if you draw the finally Mohr circle for corresponding to passive case, that again will be tangential to the envelope, and from the major principal point to the tangent to the envelope of the circle, if you connect, that line give you the failure plane, and that failure plane inclined to the horizontal is 45 degree minus pi by 2. So, that is the thing to be remember. So, when I have done for this one, so you have done this way, that was 45 degree plus pi by 2, when I am doing 45 degree minus pi by 2. So, these two things very important to be remembered, and very frequently it will be required in solving problem, or sometimes some small short time short answer type question, it will be important. Now, suppose I have mentioned that gravity retaining wall, and this is suppose a gravity retaining wall, and you can see the different forces acting on the wall. The gravity retaining wall major part, there is a gravity weight will be there, that will be acting W here, and in addition to that it will have backfill is this side. So, from backfill there will be active pressure thrust will be there on this, and this toe side, since wall is tendency to move this direction, so it is towards going this, so it will give you this portion, the passive pressure. To make a you can say conservative design, sometimes this can be ignored, but if you want to do accurate design or calculation, then this should be there. This is active, this is passive, and since there is a huge backfill here, so there will be tendency of the wall if also to slide along this. So, if it slide, then the friction will develop between the soil and the base of the wall. So, that is a frictional force to be shown. How much to be frictional force, that can be calculated, we will discuss later on. And then obviously there will be reacting force, the entire thing there will be vertical reaction to this. So, all forces are there. Once you know these forces and do some analysis, then one can find out what is active, what is passive and all. So, I will do that one by one. Suppose you can see, I will consider the wall suppose moving this way, and you can see we can take a few make a few assumptions that frictional force between the backfill and retaining wall are assumed to be negligible. Backfill and retaining wall, okay, backfill and retaining wall. This is the backfill and retaining wall, the frictional force to be reduced, this ignored. The wall is straight and the surface of the backfill is the D is not there, is horizontal. That means your wall can be like this, wall can be like this and backfill can be like this. So, this is not the case. You are considering wall suppose like this. So, backfill is like this. The backfill is homogeneous granular material. That means again here we have considered granular material. If it is a granular material, only a phi will be there, and if it is a not granular soil, then it will have C also. So, if the C is there, calculation everything will be different. So, we will see later on. And right now we are considering only granular material and homogeneous, and failure surface is assumed to be plane. That means this plane will be plane taken as a plane. It is generally little curved in the research you could find, but for approximate calculation we do the straight. If you do this and you see if this is the wall, some imaginary wall is there, then P A will be here, W will be here, R will be here, tau will be here, this will be angle beta. And so this angle beta basically at active case it will 45 degree plus phi by 2, that is there, but for the time being I took any beta and I consider this wedge, and then I got the force diagram, force polygon here. Okay. So, for a particular beta I got this, and now I can optimize for beta to find out at what value of beta the force, active force or active thrust become minimum. If you can find out that is the work actually we want. So, initially what we have done, we have taken a beta value, any value, and if it is beta, then this one H cot beta, this is W, this is P A, and these are all shown, and based on this is the force polygon. If you have this force polygon, and then by doing earth pressure will be P A will be earth pressure P A will be W tan beta minus phi. So, from that you can see from the polygon you can from the polygon P A actually P A we can find out in terms of W beta phi. So, that is the thing done. You can see P A equal to W tan beta minus phi, and again W we can calculate from geometry. This is half gamma H, that soil actually volume of soil, and then multiplied by gamma. So, this was the soil volume gamma, this is H cot beta and this is H, and then half gamma, half into H cot beta into gamma. that become weight. So, this is the weight, and this weight if I substitute here, then P A become this. This is the expression for P A, which is having beta and phi. Now, I can differentiate this expression, the P A, with respect to beta. So, that means and set to 0, that means that value of beta we supposed to get the minimum. So, if you do that, del P A del beta, and then differentiate this one and set to 0 and then simplify, then it is not so easy, of course. We have to do so many substitution, this that, and finally we will get a result is equal to 2 beta minus phi equal to 90 degrees. And if you get this 2 beta minus phi equal to 90 degrees, then from there actually I can get that means by differentiating and setting to 0, that means we are getting a angle, critical angle beta. Initially we have taken a value beta, okay, we have taken a beta. Now, that beta for which it is giving minimum value, that is I am defining as beta CR. So, that is actually 45 degree plus phi by 2. So, what I have shown initially without understanding what will be the plane direction, I have just mentioned 45 degree plus by 2. Now, we can see we got mathematically this is 45 degree plus phi by 2. Now, this beta r 45 degree plus phi by 2, if you substitute in this, then your P A will become half gamma h square tan square 45 degree minus phi by 2, and this is actually can be written half gamma h square into K. So, actually if there is a wall and if there is a backfill and the soil has been gamma, then soil pressure diagram with depth will be like this. So, area of this diagram will be half into h into gamma h, is it not, half h into gamma h, and if you take unit width, so that become the your half gamma h square become the pressure thrust, and you can see if I do not do anything, then I am getting half gamma h square. So, half gamma h square is there, and additionally I am getting tan square 45 degrees, tan square 45 degrees minus phi by 2 additional thing we are getting. So, that we are denoting as a K A, active earth pressure coefficient. So, K A will be equal to tan square 45 degrees minus phi by 2, or it is 1 minus sin phi by 1 plus sin phi. So, this is the thing you have to remember, always it will be required. So, active earth pressure coefficient either tan form, tan square 45 degree minus phi by 2, or sin form, that is 1 minus sin phi by 1 plus sin phi. So, either way one can remember. So, we got at this level what is the K A and what is the P A. Okay. So, that means if there is a wall, what is the thrust because of the soil pressure and amount, and how to find out K A from this. If you know the phi of soil, then we can find out K A, and from there we can find out the active thrust. Similarly, you can see if the wall is moving towards the backfill, say the wall was here, sorry. So, wall was it is moving this direction, it was here and then moving this direction. So, pressure will be P P, and vertical pressure is acting here, P P is acting here, and then in this plane there is shear acting, then resultant R is acting, and then what is the angle, everything is known from the mechanics. We can find out this, and then we can find out this force polygon. Okay, whatever force acting here, taking that one we can draw this force polygon. Now, from this force polygon you can find out also P P in terms of W and beta plus phi. So, if you see that similarly as we have done last one, you can see that P P equal to W tan beta plus phi, and W again you know half gamma h squared beta. So, that is also geometry. So, this is one h squared beta and this is h. So, obviously and this angle is taken beta, like active case we know that finally beta critical is 45 degree plus pi by 2, but initially what we have taken? We have taken as beta and for a particular value of beta I consider the wedge, and then I consider the force equilibrium, that is polygon we have done. Then I have find out the expression for passive pressure, and then W I can calculate, and you substitute, then you will get the Pp. This is the expression for Pp, which is having a half gamma h quad beta tan phi. So, beta and phi. So, beta generally is not known, is it not? Phi is known for soil, but beta is unknown. So, that is why we need to find out the value of beta. So, similar to that, whatever we have done in the previous case, del Pp by del beta, that means if you differentiate this one with respect to beta and set to 0, that means we are optimizing it, and then after doing this and several substitution, modification, simplification, then something cannot be 0, etc., all those things eliminate, and finally you will get a relationship between phi beta like this. So, like we have got phi beta there also, here also you have got relationship between phi and beta like this. So, this from this I can get whatever beta I get, that can be considered as a beta critical, and that beta critical will be 45 degrees minus pi by 2. Okay. So, as I have shown that at the beginning, that when wall moves towards the backfill, we have shown that failure plane will make an angle with equal to 45 degrees minus pi by 2 without knowing, just we have mentioned as a fact, but now based on this calculation we have got that this angle is 45 degrees minus pi by 2. Now, this beta value if I substitute in this, then and simplify, then we will get Pp equal to this, and so you can see that Pp equal to the half gamma. So, this is and then similarly again if I draw the pressure diagram, and this is H, and so this is gamma H. So, half gamma H into H, this is the, if I do not do anything, this is the thrust, but this is multiplied with a factor that is called Kp. So, this Kp is now Kp equal to tan square 45 degrees plus pi by 2, or it is 1 plus sin phi by 1 minus sin phi. And you can see that means if you know the phi value, then we can find out the Kp, and after knowing the Kp and knowing this half gamma square, you can find out the active passive thrust. Now, you can see that what is the relationship between Ka and Kp. We can see Ka will be equal to 1 by Kp. So, if you soil have a phi equal to 30 degrees, then you have Ka equal to 1 by 3 and Kp will be 3. If the phi of a soil is 30 degrees, then if I put Ka equal to 1 minus sin phi by 1 plus sin phi, if I do, then it gives you Ka equal to 1 by 3, or it is 0.333, and if I find out Kp value, then that will become 3 times, that means inverse of that. So, that means from the coefficient of earth pressure active and passive, this is Kp, obviously you can see that is a very large value. So, earth pressure at passive condition will be, pressure is very high. Okay. So, this so now we can see this is the one way we have tried to geometrically and force polygon we have done, and then finally introducing Ka, Kp as a name we have got, but based on Moore circle also applying Rankine's theory, we can also get this one. So, suppose we are considering a wall here, P acting here, granular backfill, at H actually sigma 1 is gamma H and sigma 3 will be it is depending upon the whether it is active or passive. So, sigma 3 will be either Ka sigma 1 or Kp Kp sigma 1, either this or that. Okay. So, I will show you in the same diagram both are happening. So, we will go to next slide. You can see this. You can see this. Initially was sigma 1 here. Initially was sigma 1 here, and then it become sigma 3 become here, and this become the Mohr circle, and this become the failure plane, and this is 45 degree plus pi by 2. So, geometrically you can find out, and this was sigma 1, and for passive case this becomes sigma 3, so this is failure. So, from here if you join this one and if you get this will be 45 degree minus pi by 2. So, so this is the one now I separately have shown. So, if I draw a envelope of phi both sides, so both the circle will be between this, and so this will be actually active and this is passive. So, now this is some observation because you can see the sigma 1 whatever value sigma 3 is larger. So, this become major actually in passive case, and whereas in active case this is minor for passive active case. So, this observation now taking this so I will now next discuss about Rankine's theory, and based on Rankine's theory how to find out the earth pressure both for granular backfill and then level ground surface, granular backfill with inclined surface. Then if there is a C phi soil also how to find out. So, all those things one by one we will proceed. So, right now I will just stop here, maybe I will continue in the next lecture. Thank you.